Okay, previously we had developed this was the stiffness matrix for a truss member in the local axis, and then we learned how we can transform the deflection vector from local axis to global axis. This is what we learned previously. Okay, so here the TM is called the transformation matrix for member AB, which connects the displacement vector UML in the local axis of AB with the displacement vector UMG in the global axis. A similar expression can be obtained for the force vectors. So the force vector PML can be written as TM into PMG, as similar to the deflection vector right over here. Okay, so I'm calling this deflection vector. It's actually displacement vector. Okay, so from equation 5, equation 5, if we put the values of UML, this UML will now turn into TM multiplied by UMG. There you go. This is what happens here. KML into TM into UMG. This is what happened. We just put the values here. Similarly, if we put the values of PML here, this is PML into this equals to this PML value. If we put the PML value here, which is going to be TM and PMG, this is the equation. We can call this equation 12. There you go. Now remember that force is equals to stiffness into displacement. So right over here, this transformation matrices are actually a part of the stiffness matrix right over there. So we're going to interchange them. If TM goes from this side of the equation to this side of the equation, it becomes TM inverse. So we have TM inverse KML and TM as the stiffness matrix multiplied by the displacement vector equals to the force vector. Okay, so here a TM inverse can also be written as TMT, where TMT is the transpose of the transformation matrix TM. Okay, so if TMT, KML and TM is written as KMG, meaning stiffness in the global axis, then we get this equation. We get this matrix by multiplying these three matrices, which is a difficult task to do. That is why I'm not putting it here, because you don't need to do that each and every time. Once you do that and you develop this matrix, you can always use this matrix to solve problems of 2D trusses. Okay, so here we have KMG, meaning the stiffness in global axis for the truss members, is equals to Sx being the axial stiffness. And then we have here the formulation where C is referring to cos theta and S is referring to sin theta. Now this is the matrix that we need to memorize, we need to remember for solving problems. But there's an easy way of remembering this. You don't need to memorize it. What you need to do is, let me see, there you go. If you just memorize the top part of it, if you just memorize the top part, this is the top part, you can see that all other parts are similar. Now this is C squared, here CS, and S squared. Here is the same thing but in negative. Similarly, this side is the same thing but in negative. And then again we have this side in the positive. Okay, so you can easily remember this KMG matrix. Right, so that is it for this video, and we'll be seeing you in the next one.